Okay, so for this lesson, it's 4.9a. We're going to be looking at some systems of quadratics and lines and all that jazz. So this one they want you to graph and then check your answers afterwards. So let's graph the top equation. It's always good to find the vertex of this. So the opposite of b over 2a is going to be negative 2 over negative 2, which is 1. So the vertex for this one's going to be 1, comma. Let's plug 1 in and find out what it equals. The opposite of 1 squared is negative 1, plus 2 is negative 1, sorry, positive 1, and then positive 1 plus 1 is going to be 2. So the vertex is going to be at 1, 2. The y-intercept is going to be at 1, so I can put that there and the point of symmetry right here. Can also choose another point. Let's try 4. So y equals negative 4 squared plus 2 times 4 plus 1. So y equals 4 squared is 16, 16 minus, and a negative 1 is 16, negative 16 plus 8 plus 1. So that is going to be negative 7. So 4 comma negative 7 be right here, and the symmetry point would be right there. So if I draw this, it's not really perfect, but it's good enough, I think. Then we want to graph, this is just a regular line here. So let me just choose another color here. Okay. This line over here has a y-intercept of 1 and a slope of 2. So up 2, right 1, up 2, right 1, up 2, right 1, and down 2, right 1, down 2, down 2, left 1. So it's a straight line, so let's just get a regular line and draw that right down here. Let's put some arrows on it. Remember, the solution to this is going to be where the graphs intersect. And for this problem, they're going to intersect right here. If you were to use your calculator and blow it up, it would be at 0, 1. That would be the point of intersection. So that's the answer right here, 0, 1. All right, this one we're solving by substitution. So because we know what y equals, we're going to substitute in for y. So we're going to have x plus 1 equals x squared plus 4x plus 1. Let's move these terms over to the right side since the x squared is positive over there. So we're going to subtract x and subtract 1 from both sides. So we have 0 equals x squared plus 3x, and then those cancel. To solve for x, we have a GCF of x here. So let's factor that out. So it's completely factored. So set each of these up equal to 0. So we have x equaling 0 or negative 3. Because if you set that up equal to 0, you get 0. X plus 3 equals 0, you get negative 3. This means we're going to have two answers. One of them has x being 0, the other one having x being negative 3. So to find out the y values, we're going to be putting 0 and negative 3 in for x. I would put them in the second one since it's an easier equation. So if I plug in 0 here, y equals 0 plus 1, or 1. negative 3. So y equals negative 3 plus 1, it would be negative 2. So these would be your answers. Number 3, solve the system. Let's substitute. So let's take this and substitute it in for y. So we'll have x squared plus 2x plus 1 equals x squared plus 5x plus 1. Subtract x squared from both sides. That cancels on both sides. Subtract 1 from both sides. Those cancel on both sides. So we have 2x equals 5x. So we can subtract 2x from both sides. So we get 0 equals 3x. So that means x can only be 0. So our first point of intersection, and the only point of intersection, is going to be when x equals 0. So let's plug it in, let's say for the bottom one. 0 squared plus 2 times 0 is all 0. Plus 1 is 1. So that's your answer. Alright, number 4, they want you to solve this by graphing. So let's graph this top one. Let's find the vertex. So the opposite of b over 2a is negative 1. Let's plug negative 1 back in. This is 1 minus 2 is negative 1. So that vertex of the first one is right here. Let's find some more points on this one. This has a y-intercept of 0. So let's plug that there and there. If I plug in 1, I get 1 plus 2 times 1, so that would be 3. So you get that point and that point. Let's do 2. 2 squared is 4. 4 plus 2 times 2 is 4, so 2 comma 8. And the point of intersection there. So let's graph this as close as we can. That is impressive. I just impressed myself. Alright, so let's do the second one now. Second one down here. The vertex, since it doesn't have an x term, is going to be at, let's do this color, at 0, negative 1 right here. It's not the best color. Let's do it in red. So 0, negative 1. It's the y-intercept and it's also the vertex. If I plug 1 in, 1 squared minus 1 is 0. So the point symmetric is here. If I put a 2 in, 2 squared is 4. 4 minus 1 is 3. If I put 3 in, 3 squared minus 1 is 8. And if I put a 4, it's going to be beyond it. So let's see if I can do just as good on this one. Not too shabby. Alright, so we have some inequalities here. The first one, the black one here, is greater than. So if I shade everything greater than here, and if I were to shade everything greater than the red, the overlap would be in between, from here down and then here. And we can try to do that. I think it'll be kind of hard, but let's just try it anyway. It's kind of hard to do this. Let me just erase some of this stuff here. Okay, and then let's do the red. So the red is going to be, I'll go the other direction. Okay, so our answer is going to be the area that the red and black touch or get together. So I'll do that in blue. It's going to be from here, and I just made a big boo-boo. Do you know what my boo-boo is? It's not Yogi's, who was Boo-Boo? Was it his son? Was Yogi's son Boo-Boo? I don't know if you guys are too young to remember Yogi Bear, but he had a little bear next with him. You guys should know that from the movie. It was an awful movie. Boo-Boo, I think it was his son. I'll have to Google that later. Anyway, my mistake was in reading these signs, it's greater than. And let me just check if I screwed up the other one. No, okay, that's fine. These are greater than signs. They're not greater than or equal to. So these technically should have been, if I can do this, and do that. They should have been dotted lines. So the solution area is going to be, this is dotted up to here, and then dotted here, and everything in between. So your solution area should look something like this. It hits here and then it goes up, and then everything in between those. That's what the solution set should be, solution area. Remember, it's dotted if it's not less than or equal to. If there's no equal to sign here, then it's not a bold line, it's dotted. Alright, let's see if I can not screw this one up. Solve the system. So what we're going to do is we're going to, since we know what y is, we're going to substitute that in for y. So we have negative 4x plus 25 halves equals 1/2 x squared plus 4x plus 4. If you just hold on 1 minute, I'm going to Google that Yogi Bear thing. I'll be right back. Alright, I'm back. This is Boo-Boo over here. I just looked it up. They say he's just a companion to Yogi Bear, so he's not his son or anything. I thought it might have been his son. But it also said that they don't know if Boo-Boo's a juvenile with it said something like a precocious intellect or something, or if he's an adult bear that is short of stature, which is FYI. I thought it was pretty funny. Maybe you don't. Maybe you think this was all a waste of your time, but I'm pretty excited now that I know that. Alright, so we substituted. Now we want to get rid of the fractions because we don't want to work with those. So let's just use brackets and multiply both sides by the common denominator, which is 2. So we're going to have negative 8x plus 25 equals x squared plus 8x plus 8. So let's move everything to the right because x squared is positive over there. We're going to be adding 8x over, so that's going to make it a 16x. And we're going to be subtracting 25 from 8, so that's going to be minus 17. If you look at this, there's a combination of 17 that adds up to 16 because if there's a difference. So we can have a factoring here. So x plus 17, x minus 1. That's the product is negative 17, and if you add them together, you get positive 16. So my x's are going to be the solutions of these. So negative 17 or 1. So that tells me these are going to hit at 2 spots, when x is negative 17 and when x is 1. Boo-Boo says hi. Sorry. Okay. Well, you can tell today is a Friday. So let's let these go into x. So let's substitute. Let's put the negative 17 in. So y equals negative 4 times negative 17 plus 25 halves. When you do all that out, this is 68. 68 plus 12 and a half is 161 halves. Which is 80 and a half, roughly. Not roughly, it is 80 and a half. So when you plug in 1, what you're going to get is y equals negative 4 times negative 1 plus 25 halves. This is going to be 4 plus that, and then you get 17 halves, which is 8 and a half. So these are the 2 points that intersect here. Okay, number 6. We're going to want to solve this by graphing. So for the vertexes, so the vertices, the first one is going to have a vertex of negative 1, or at 0, negative 1. And let's plot a few more points on this one. So if I plug in 1, 1 squared is 0, sorry, 1, and then 1 minus 1 is 0. And the point is symmetric, is there. If I plug in 2, 2 squared is 4, 4 minus 1 is 3. 3 squared is 9, 9 minus 1 is 8, so 3, 8 here and here. So if I connect all these, again, very impressive. Alright, the second one, let's do that in red. The vertex is going to be 0, negative 3 again, because B is non-existent here. If I plug in 1, 1 squared is 1, 3 times 1 is 3, 3 minus 3 is 0. So we have those 2 points. If I plug in 2, 2 squared is 4, 4 times 3 is 12, 12 minus 3 is 9. So let's put that point here and here. So let's connect this. Okay, now if you can, and there you go, I did it again. These should both be dotted lines. So let me just do a little cheat way of doing it. Okay, they're dotted lines because they're not equal to. So the area that is going to be the solution area, if you think about it, this is the black one. You're going to be shading everything under that. So everything under it. And then for the red one, you're going to shade everything above it. So if you can picture that, this area here is going to be the solution area. So that area right here. And let's bring out the calculator just to show that. So let's turn it on. That's a different problem. Okay, so y is less than. So let's go over here and hit enter, enter, enter. So you see the little triangle on the bottom. That's less than. We're going to do x squared minus 1. And over here this is greater than. So let's go over so that it's a triangle on the top. That's greater than 3x squared minus 3. And then graph that. That's the first one, everything underneath it. And the second one is everything above it. And we can zoom in on here. Let's do that. Let's make a box around it. And you can see it clearer there. That this is the black one, this is the red one, and you see almost like looks like a smiling mouth here. That is the area that is shaded, and that's what that represents right here. Alright, number 7. And I was told to give a shout out to somebody, so I'm going to shout out to that person. You know who you are. Okay, number 7. Simplify. So we're going to be foiling this out here. I should do that more often. Just give a shout out to people. I'm going to give a shout out to Johnny Cash right now. He passed away recently, but I'm just going to still give a shout out to him if you can hear me. Johnny Cash. Alright, so 3 times 2 is 6. We're foiling. 3 times -1. Sorry, negative I. 3 times negative I is -3i. 2i times 2 is 4i. 2i times -i is -2i squared. -2i squared. The I squared is going to turn this into a positive 2. 6 and 2 is 8. -3i plus 4i is a positive 1i. Number 8. I'm going to give a shout out to Ronald McDonald. Him and his enormous shoes. Alright, now that that's taken care of, rewrite in vertex form. So y equals 2x squared minus 8x minus 3. So when we want to go from standard to vertex form, we're going to use a little bit of completing the square. So let's add the 3 over. Okay, now our next step is factoring out the lead coefficient from both of these terms and leaving a space. Half of that squared is 4, so it's 2 times 4 is 8. And then we simplify, so y plus 11 equals 2, x minus 2 squared, and it's in vertex form. Number 9. I'm going to give a shout out to the Ewoks of Star Wars fame, Return of the Jedi. Alright, number 9. The vertex here is the -9, comma, -4. Axis of symmetry, that great heavy metal band. X equals -9. So x equals that value. It's opening up since a is positive, so it's going to have a min value of -4. Domain is set of all real numbers, and the range is a set of y's such that y is greater than or equal to the minimum value. And number 10. Okay, when solving a quadratic system of equations by substitution, which variable should you substitute for in order for it to result in a simpler equation? So let's just say, for the heck of it, we have y equals 2x squared plus 1 and y equals 3x squared minus 4x minus 7. What variable should you substitute for? Well, it's kind of clear that you want to substitute for the y variable because it's already solved for y. If it's already in the form y equals something and y equals something, you're going to want to take all of this and substitute it in for y over here. It wouldn't make any sense to solve for x here in terms of y and then stick that in for x, because that would be a pain. You'd have to subtract 1, divide by 2, take the square root of both sides. You'd have square roots of stuff, and it would just be nuts. You wouldn't want to do that. It's already solved for y, so substitute for y. And when you write this out, use complete sentences and all that stuff. Sophisticated math language, just like I used all of that stuff. That's sophisticated math language. Not really, but you know how it is. I also want to give a shout out to the ruler. Any ruler at all. Just there's your shout out. Have a good weekend. Well, if you're watching this on Monday, then I hope you had a good weekend. And if you're listening to it on Wednesday, I hope you had a good weekend, and I hope you have a good weekend. I'm going to end this right now.